Alright YouTube, here we go, little iManifold reporting video. So this is the iManifold as we enter it in. So our application's here. We're going to go ahead and go to a custom new profile system. I'm actually going to profile my system here at the house. We're running the R410A system. Running a heat pump. Standard expansion valve, 15 SEER system, high efficiency evaporator, target superheat. We're going to put usually 12 to 15. We'll put 12. Target subcooling for my unit is going to be 10. And then we are going to create the quick profile, submit it. Create quick profile. Please confirm that you'd like to create a quick profile. Well, I'll say that 3 times fast. If not, the current settings will be applied to the iManifold without it. So we want to create that, and I'm just going to name that My House. Enter, and there we go. You can see up here now it says My House. So I'll move on to the next step here, which is going to be going outside and actually taking our measurements. So let's go take some measurements, guys. Alright guys, I got my 15 SEER American Standard here hooked up. Took the service panels off there. Got my meter, my wrench, my iPad, the iManifold, and my thermometer down here, which is taking the temperature of the outdoor air entering the condenser. So basically I'm going to hook the iManifold up to my system and then move inside and start remotely monitoring things. The unit's been running for about 5 minutes. So let's go ahead and press the power button here. You can see that all of our LEDs light up. I'm going to go ahead and take the low side off and then take the high side off. Now just to make sure there's no pressure in the system, I'm going to go ahead and open up all my ports. And then I'm going to connect the iManifold here. Let's try to move away from the glare. Oh, wrong side. Let's go over here. We'll connect the iManifold. We are connected. I'm going to sample the rate at the high. Now I'm going to zero my pressures out. I will confirm it. Close this. Now let's go over here and make sure we tighten them all up. Finger tight. I do like the imperial gauge because you can replace the diaphragms in there in the field. You cannot do that with your Testo 557s. So let's take our wrench down here. So one of the only times you'll see me not wearing gloves, guys. Alright, let's go ahead and hook up our high side. Shall hook up our low side. Alright, make sure everything's open. Now see we're reading pressures that fast. Alright guys, we hooked up our pipe straps here. Got one on my liquid line, one on my suction line there. And we're still at 80 degrees entering air temperature. And now you can see that we've got a superheat and a subcooling now. So our unit's been running for about 8 minutes now. And we got the good superheat and subcooling. So let's go ahead and take some measurements and see what our total amp draw on the unit is. Let's get our incoming power line. Man, I need a hat cam. And we've got 6.6. And let's see what we got on line 2. Again, we've got 6.6. Alright, let's look over here and see. We got line 1 to ground, 120 volts. 120 volts. Line 2 to ground. Okay, now we have moved inside and we're still remotely monitoring the system. And I've also casted it on my television. So through Apple TV you can actually cast screen images of your iOS devices on your television. So pretty cool. Just got up there so it's big and easy and I can see and reference. And I can take this up there in the attic with me or leave it down. So right now I'm going to leave it down. I'm going to head up to the attic, which is here. So I've got some, my static pressure gauge, manometer, my amp probe, and screwdriver, and I got to drill a hole to get a static pressure reading. So got that. So let's head up, guys. Right there. Alright guys, so here's our air handler. Got a media filter on it, and I'm actually going to drill a hole right in there so I can get my static pressure after my filter. And then I'm going to put one in my plenum on the top of the plenum here to take my static pressure there. I'll also open up my disconnect, take this off so I can get my voltage, line 1, line 2 to ground, and my amp draw from the air handler. So let's go ahead and prime everything and get it ready, and then I will show you what it reads. Alright, we got our hole drilled in there so I can slide my psychrometer inside here. I'm also going to put it inside the supply so I can get the relative humidity and the temperature. And I'll also put my static pressure gauge on that. Let's get it hooked up. So now we are zeroed out on our static pressure gauge. 0. And let's go with port 1. And we're going to put that inside there. And we've got negative 0.17. And let's go ahead and put this one over here. And you can see our total external static pressure is 0.39 now. So, just for giggles, let's go ahead and switch them over. So I've just basically reversed them, and we see we've got 0.37, 0.38. So that, guys, that's how you take a static pressure reading. Probe there, probe there. This is a heat pump, 2-ton, 15 SEER. So we'll pull these probes out now and test for temperature. So let's put this in here. We'll let it equalize and come back. So guys, we now have 43% relative humidity coming in, and we're 89.4 degrees coming in. 89.4 seems kind of high right now, but I need to go ahead and test that and see what's up. Let's put this probe in here, and we'll let it equalize as well. And I thought the last measurement was a little high, so I went ahead and shoved my other one in there, and it is reading 83. So probably not too far if we're going to stick with the same device for accuracy. And we're reading 83% humidity and 53.6 degrees coming out. Alright, so like any good installer, you'll put a loop around so you can get your readings. And amp draw, we're reading 0.93 on line 2, and line 1 we are reading 0.991. And our voltage from ground to line 1, 120, ground to line 2, 120. Alright guys, I wanted to just do it a separate location other than the hole that I drilled, so I went ahead and popped the hole right in here because I don't think that was really operating correctly, giving us the right temperatures inside there. So I went ahead and ran it here, and we're looking like this is more normal reading here. 50% at 75 degrees, and it's 75 in the house right now, so that's going to be a correct humidity and temperature reading. I think we were getting some air leakage when we were right in that hole right there. I just put a piece of foam tape on it. Kind of ugly, but that's all I had up here. So got our correct readings. Let's go ahead and go downstairs. Alright guys, the unit's been running for about 20 minutes, so it should be nice and settled out. And we'll use these right here. We'll actually use a snapshot feature on the iOS to snap a photo of that. Then I can draw the values from it. Alright, here's how we got our airflow settings. This is an airflow performance table. So we're looking at the normal 2-ton speed, which is where I have it set at. And we're looking at our 0.3 external static pressure. And we cross-reference those over, and we're looking at about, between 0.3 and 0.5 is only like 5 CFM difference. So 845 CFMs is what we're looking like there. Now this is a wet coil with a filter in it and no heater. So we've got to go down and look at, with the heater, what it will be. So here we are, we got a heater rack. There's our model number. We got one rack. And if we go at our airflows, we're on 800. We've got one rack, 0.02 inches of water column. So, that's so small, it's not going to make a huge difference at all. Just wanted to show you guys that and how to read static pressure to get airflow. Alright guys, I'm going to show you how to enter all this information on my phone, because Apple does not have the reporting yet. If you notice, maybe on the other previous screens it was showing, just the system performance. And actually I didn't realize that reporting wasn't there and wasn't out for the iPad yet until I started loading the video. And I'm like, oh crap, I need to go ahead and take care of that. So anyways, I'm going to go in and just do all this as user inputs. You can go in and tag the equipment and it'll automatically upload, and I'll show you guys how to do that. But for right now, we'll go over here to user inputs, and we'll basically enter in all of our inputs. So our suction pressure was 117.7. Our head pressure was 281.2. Our gauge temperatures, suction line temperature was 59. Discharge line temperature, we did not take that temperature. Liquid line temperature 83. Outdoor air temperature was 80. Air across the evaporator. The return dry bulb was 75.2. The supply dry bulb 53.6. Return relative humidity was 50%. Oops. And this is 83%. And keep in mind, guys, when you have all the probes hooked up to it, this it lets you know everything real quick. It does a snapshot. Actual airflow was 845 CFMs based on our chart. We got a nominal 2-ton unit. The electrical here, we're running a split system, not a 3-phase, single phase, 240 volt. Line 1 to ground 120. Line 2 to ground 120. Line 1 current was 6.6. Whoops. There we go. And the same for line 2. That was our condenser, so our power factor is going to stay 0.95. Our air handler is different though. We got a single phase air handler. Voltage is 240 volt. We're not running a PSC motor, we're running a variable speed. So ECM. And again, we've got 120. And we've got amp draw. Was 0.99. Voltage 120. Now that's the ground. That's not L1, L2. It's L1 to ground, L2 to ground, and then this was what, 0.93. Power factor on that is 0.65. And we shall submit. So that's going to plug all of our data, all of our information in there. And then we can go to system performance, and it'll actually tell us barometric pressure, airside psychrometrics, temperature split, target temperature split, deviation from target, dehumidification, actual airflow, BTUs an hour. I mean, you name it, man. This thing will tell you it all. Even the bypass factor, that's awesome. Current EER, total watts of your unit. Pretty sweet. So then we can go over to the actual reporting side, and we'll start a new session. It's already got my information loaded in it. You can put your customer information in there, name, email. And then our system profile. Let's go in, and I've got a 15 SEER R410A TXV system. Back to reporting. So system profile has been loaded. And let's make sure that actually system profile. Let's equipment profile. Let's edit that current. Make sure our subcooling and superheat was right. So we're running a 13 to 16 SEER 410A unit with a TXV valve from the indoor. 410A refrigerant, heat pump, standard TXV. We're running a 15 SEER, so 13 to 16 is going to do there. Evaporator type's high efficiency there. Target superheat's around 20, target subcooling's around 10. And we can submit that. And we'll use the entered name. You can actually auto name it or enter your own name. So now we'll go back to reporting. And you can enter the model numbers and serial numbers of the unit in here. I have not done that. I'm being lazy. And work performed, notes, you can go through equipment service, new installation, or retro for commissioning. Pretty cool there. Now we'll just name this equipment service. I'm not going to put any notes in. And then we can take a snapshot. Now this is what's cool. While you got all your probes and everything up there, you can take a system snapshot. And that will, since we've got everything auto-programmed in, it automatically gave us our evaporator performance, system capacity, dehumidification, and our efficiency. Once you have all the probes up, all you do is come down here while it's reporting and hit take snapshot. Boom. It automatically loads it in, time stamps it for you, date stamps it, and then now you can email this report. Let's say I'm going to email it to I've got my corporate account in here right now. I can actually add an email. So let's put on my personal email, jtmacola@gmail.com. And we're done. So we will add this email. Now we'll choose it. And now we will send the report.